All right. Well, I think welcome everyone. Unfortunately, we've had some IT problems this morning, and very much apologise for the late start. But my name's Neil Warburton, and I'm chairman of Belararox, and certainly like to welcome everyone along to today's presentation, which I think you'll find extremely encouraging. Belararox has had a fantastic last couple of weeks, as you would have seen with the ASX announcements. We've been able to obviously finalise the acquisition of the TMT project, and this morning we actually put out the porphyry prospectivity report by Dr. Stephen Garwin, who's on my left with the beard and the curly hair, and we've also got Jason Ward. Jason is our country manager and our chief technical advisor in Argentina on the TMT project. And these very renowned, experienced and very professional geologists are going to go through today's announcement, which I said earlier on, I think you'll find extremely encouraging. So without further ado, thank you for everyone for attending, and I'm going to hand over to Jason Ward, and Jason will introduce Stephen. Over to you, Jason.
Okay, thanks, Neil. And yeah, thanks everybody for attending. Yeah, this is very exciting days for BRX. The TMT project is a great project which I've had my eye on for a very long time. I lived in Argentina since 2004. I knew about the Toro project. It's very hard to get ground in San Juan. San Juan's one of the highest, best, most mineralized places on Earth. All the companies are in there. To get 320 square kilometres along that belt is very difficult. We were able to put all this ground together, and BRX has a wonderful opportunity now to make a discovery. I've long liked the project, and I was very encouraged to bring Steve in and to hear Steve's thoughts on it. Dr. Steve Garwin is the best porphyry geologist that I've ever worked with. I've worked with him for many years. We brought him into Ecuador, where he trained the team in anaconda mapping and just putting data sets together and really getting the most out of your data. So I'll hand it over to Steve to take it away.
Thank you, Jason. I'm going to go ahead and share my screen and presentation. Just give me a moment to get myself organized on that. Okay, Jason, can you confirm that you're seeing the investor presentation title slide?
Yes.
Great. Okay, I have not been to site. I have looked at geological data provided by Belararox and satellite imagery processed by a group known as Fathom Geophysics out of the US. And basically, this is using satellite-derived data such as ASTER and Sentinel-2, which take images and measure various strengths of various bands that are available in satellites of the Earth's surface. This has been collected for a very prospective region in the San Juan province, northern San Juan province, which contains the TMT project of Belararox. And so from this, I won't go into the details of the science. That's provided by an internal report by Fathom Geophysics for the company. However, I will show how one can use the images and the vectors derived from the processing of the satellite data to help infer the presence of large-scale magmatic hydrothermal systems, which can lead to the deposition of copper, gold, silver, molybdenum in porphyry style and epithermal style deposits. Now, this presentation is an extract from a more comprehensive report that I delivered to Belararox about 9 days ago, some of which is summarized on a press release put out to the ASX this morning. Again, I can let you read that at your leisure. Jason is the competent person. However, I am qualified as well, but for Belararox, Jason is the competent person, and this is important legal information. So now, just to introduce the area of interest, this is northwestern Argentina. As Jason said, this is a very prospective portion of the world for copper, gold, silver, lead, and zinc. It shares a very long border with Chile to the left. And here we have, this is a paper written by Ford et al., where they document the various gold systems. And the study area that we'll be discussing today for the satellite hydrothermal alteration study sits basically between Veladero to the south and Filo del Sol to the north. And what we can see is this portion, very gold, copper-rich portion of Argentina in the northern portion of the San Juan province, occurs on the edge of a major Precambrian basement block associated with sort of a tertiary arc system. So that all that means is a lot of volcanoes were formed and have been partially eroded since formation about 15 to about 2 million years ago in this part of the world. And so there's still active volcanoes in the region. Now, this is if one were to take use a topography determined from satellites, the Shuttle Radar Topographic Mission, SRTM topography, again, measured from space. And on the left, we have a map showing the elevations above mean sea level for Argentina and Chile. So far off to the left where it becomes blue into white, that's the sea on the coastal plain in Chile. And these various deposit types, black for copper, porphyry style, high sulfidation systems, yellow for gold, silver, light blue for silver, lead, zinc, are shown. Now, the study area is shown on the right-hand diagram, and what those various colored squiggles, very technical term there, indicate is basically processing of the satellite-derived topography to show where the steepest portions of the mountains are. It doesn't mean the highest portions. The diagram on the left, the more red, the higher the portion of that above mean sea level. On the right, it's showing you where we basically have steep ridges, all right? And one can interpret this, and I've gone ahead and made some lineaments, basically showing the not only the parallel trends to the Andean trend, which is north-south in this diagram, but you can see these cross structures that are inferred, these northwesterly trending cross structures, which correspond to disruptions in the topography. And this is because the geology has a profound effect on topography. The deposits have formed relatively young in the last several million years, but the different amounts of alteration, the amount of fracturing and faulting, the different rock types have a varying degrees of weathering. So that's how the geology can affect the present day topography. So now we can see the location of the study area, basically in an area on a major north-south trend adjacent to the Argentinian-Chilean border, associated with these northwesterly and northeasterly cross structures. And these cross structures are fault and fracture zones and zones of intrusions that can lead to hydrothermal alteration and the formation of these deposits, which are listed here. So again, we're in this sort of La Fortuna, Filo del Sol, Pascua, Veladero, El Indio region. This is something you can get off of Google Earth or Landsat imagery with the red zones correlating to just visual zones of hydrothermal alteration. So in other words, this is what you can see from space. Casually, without having to process the data, you can go to Google Earth and see this. So we have the deposits in black, yellow, and blue, copper, gold, and silver, lead, zinc. Many of them are named here. Some of the very giant copper gold resources in the world are in this region. And then what we can see here is a published paper that talks about the regional gravity database. So the gravity database is determined from land-based stations, which has then been contoured to determine zones of dense rocks, which are red, and the zones of less dense rocks, which are blue. And this has been corrected for topography. That's on the left-hand image, and you can see the Toro region, the TMT project area, is right on a major northerly trending gradient from sort of red, dense rocks to the left or west to blue, less dense rocks to the right or east. And then what we can also see on the right-hand diagram, if one were to process this gravity data and determine where there's major gradients. So for example, where you go from dense rocks in red to less dense rocks in blue, we have a major gradient in gravity. And that's what these lines or worms are telling us. And one can interpret that and can pull out these, again, very strong northwesterly oriented cross structures, some northeasterly structures. Some of these structures parallel known trends of mineralization, such as in the Maricunga Belt, which continue all the way through Chile and even into the coastal plain. And the distribution of some of these northwesterly structures help localize IOC deposits of Cretaceous age. So these are long-lived fault and fracture patterns which have jiggled and displaced rocks of various density. So what we're starting to see now is patterns, these northerly trending Andean parallel trends, these northwesterly and northeasterly cross structures that we can see in topography. We can also see this in gravity. We can also see it in geology, which is another talk. So now I'm going to zoom in to the results of this satellite-derived spectral study. So now that box that was shown in the previous slide, this is what we're seeing here. It's about 125 kilometers north-south by 85 kilometers east-west. And then we have these balls are basically copper, gold, lead, zinc deposits and large prospects. And you can see that they're named there. So we can see Veladera and Pascua. We can see La Fortuna and Filo del Sol. And in the green outline is the TMT project. And there are some known prospects that have been compiled from various databases, Argentinian Geological Survey. And we see the Cerro Toro, gold, silver, lead, zinc prospects, and the Rio La Sal Uno and Rio La Sal, which is in the northern portion, or the Tambo Sur portion of the TMT project. Now, these lines here, which are color-coded on the left, they're colored by azimuths or strikes. And so what we're doing is that from the satellite imagery and the processing done by Fathom Geophysics, they're basically telling us where there's zones, coincident zones of iron oxide, such as a mineral jarosite, for example, which is a mineral that forms from the oxidation of sulfides such as pyrite. It's got iron in it, and it's got sulfur in it, it's got potassium in it. It's a very yellowy sort of mineral. So it tells you there was an abundant sulfides in the rocks that have since oxidized to iron oxides. This is also telling us where there's kaolinite, which is a part of alteration and weathering related to argillic alteration, where the hot water is coursed through the rocks, and phyllic alteration, which is telling us about quartz, sericite, and pyrite. So basically, these linear zones are zones that have a strong response that would be consistent with a lot of clay and mica and iron oxides and sulfides that would have been introduced into the rocks by fractures and faults adjacent to intrusions by hydrothermal alteration. So the left side is color-coded by azimuth, and the right side is color-coded by intensity. So yellow is less intense, and burnt orange is more intense. And you can see the strong northerly trends, west-northwesterly trends, and northeasterly trends, and how many of these satellite-derived zones of alteration coincide, and the intersections of these zones coincide with known ore deposits, completely separate databases. But what it's saying is that these ore deposits are related to zones, massive zones of hydrothermal alteration, which can be seen from space. And by processing the satellite data of ASTER and Sentinel-2, we can further quantify the types of clays, which we can then determine, do those clays form at higher temperatures or lower temperatures, determine proximities to heat sources such as porphyry copper deposits and intrusions. So I've taken a big black crayon basically here and digitally drew lines where I thought were the more important, more dominant linear zones that are related to alteration and the location of these copper, gold, silver, lead, zinc deposits. These are the deposits that you would get out of the database, prospects and deposits from the Argentinian survey. And what I then did is, in the area of the TMT project, that green outline there, we derived about 11 targets that are dominantly based upon their satellite spectral response. Okay, and that's the formation of this study and limited geology. Keep in mind, much of this area has not been mapped in detail. When I say this area, I mean the TMT project area. But there are clear anomalies that can be seen not only at this scale, but at more detailed scales, and we'll discuss that in subsequent slides. And the question is how accurate at predicting mineralization is a satellite-derived hyperspectral study? So we'll do that by looking at the anomalies within the TMT area, but then we'll also compare it to known deposits such as Veladero in the south and Filo del Sol in the north. And then we can decide on how useful this particular package of data and processing and interpreting in this manner is, then to help us decide on how interested we are in the anomalies and prospects within the TMT project area. So that's the rationale. So now we're zooming in, and now you can see the project area in green. We're zooming into these medium scale wavelength anomalies. So again, where it's orange and red, these are satellite inferred zones of hydrothermal alteration. And then based upon the complexity of those zones, I've given it sort of a basic ranking. So A-class targets are considered to be better than B-class targets. And A1 and A2, they could be the same, but they're probably better than A3. So generally, within each target class, we go from the highest priority number 1 to the lowest priority number 3. But given how the study was done, and it's sort of really quite semi-quantitative, the ranking, A1 could be the same as A2, or it could be better. So we can see where these anomalies are. On the left-hand side, you can see the labeled tenements. And then on the right-hand side, you can see the ranked targets and the tenements that they occur in. So we'll focus today on these sort of Tambo Sur 5, 1 and 2, Malambo, and Toro targets. There are other targets as well. Now, these targets were known about. And so it's helped us kind of quantify and understand their relationship to inferred geology and hydrothermal alteration. But there's also some new targets that hadn't been well defined by the company. So now we'll go to Tambo Sur, particularly 1 and 2, but we can see the scale here. So that's 3 kilometers. So that's over 2 kilometers there. And the overall zone is probably over 4.5 kilometers long. And what we can see from the ASTER modeled imagery, we can see zones that are characterized by white mica or muscovite. Very high percentile, the 100th percentile is the very best, right? So we're 95th and 98th percentile in blue. And this is telling us typically temperatures that are above 220 degrees, maybe even above 270 degrees if it's very, very crystalline muscovite. Porphyroite is a mineral that occurs in advanced argillic alteration, typically at pHs of about 1 to 4. Often this can occur close to intrusions or close to porphyry centers. Muscovite is not quite so acid, more neutral, but also higher temperature. And you can see distal colors in green. These are chlorite and epidote. So these are propylitic minerals that occurred often at temperatures anywhere from 230 to 280 degrees Celsius, but they haven't seen as much hot water as the muscovite and the porphyroite. And along with, I haven't shown it in this diagram, but there's also kaolinite commonly with the porphyroite, and in red is the jarosite. And remember, jarosite is a hydrated sort of iron sulfate potassium bearing mineral that forms after the weathering of pyrite in zones of added hydrothermal potassium. In other words, this is all a good sign for hot water having coursed through the rocks. The next step is to determine how much metal was carried by these hydrothermal systems. And that's typically done with a surface sampling, drilling, and field work. So we can interpret the porphyroite zones there in yellow, or we can see in blue these muscovite-rich zones, and then jarosite. So what you're seeing is a nice sort of bullseye pattern. You can infer that there perhaps is a north-northwesterly trending structure with this snail shell related potentially to an intrusive center and setting up a convective magmatic hydrothermal system around it. Now that's an interpretation. Field work will further prove or disprove this hypothesis. But keep in mind, we're going to compare this same sort of spectral data to known deposits in a moment. So here are these linears, also showing these linear zones of iron oxide, kaolinite, and phyllic alteration as a base map to the ASTER mineral zoning that we have shown here in the legend. And then I've inferred potential fracture zones and faults that have acted as conduits. And these are probably the more interesting conduits inferred from this database in the target areas. One target area there, another target area there. And you can see that there's lovely zones of intersections of these linear zones of inferred alteration. And then we have the lovely metal zoning also. So this northern target is somewhat interesting. The southern target is more robust. It's got larger and more abundant hydrothermal alteration minerals such as muscovite, paraffinite, and substantial jarosite, which would be iron oxide from weathering sulfides. Something else that the satellite can do for us is determine how crystalline the muscovite is. Where there's muscovite, how crystalline it is. This is telling you basically the more crystalline, the closer the spacing between the sheet silicates that make up the muscovite, the hotter temperature of formation. Now, if you're looking for a porphyry, you're generally looking for higher temperatures, whereas epithermal would be more distal. Porphyry is getting into zones of above 270 degrees, 300 degrees, up to 500 degrees Celsius, is where we would expect to find more crystalline mica. So you see there's a very zone of more crystalline mica, which could be consistent with higher temperatures of formation when that hydrothermal mica formed. And then I've contoured out here zones of higher crystallinity. And then we can compare that to the inferred structures from the previous slide and the metal zoning. So that southern center is very interesting. Higher temperature, it's got lots of muscovite, paraffinite, jarosite. The northern center is interesting, but not quite as intense or as large as the southern center. Something else that can be done from space is looking at the thermal response from ASTER. And in this part of the world, and in other parts of the world too, but certainly in this area, it's clear that the greater the thermal response is, the greater amounts of silica, quartz in the alteration assemblage. So what we're seeing here is zones of higher thermal response and hence more likely more silica. The silicon can be added by hydrothermal fluids, or it can actually be everything that's not been leached. So you might have a rock that's got 60% silicon dioxide on it naturally, as a granitic intrusion might have. But if we leach out all the rock, all the minerals that don't have the silica and turn them into clay and wash that out of the rock with this very acid hydrothermal alteration, the rock becomes more silica rich by removing the non-silica rich minerals. So again, this is indicating the zone of silicification in the southern target area of Tambo Sur and 1 and 2 in a zone of highly crystalline white mica with paraffinite, muscovite, and jarosite, again deduced from satellite responses. All these responses are consistent with a potential mineralized center that could have copper, silver, and gold associated with a high sulfidation system or a porphyry center. But it could be something else too, but it's consistent with that. So now we can go ahead and look at nearby deposits and see how they're expressed to better evaluate the appropriateness of using this method in this region for determining prospects in the TMT project area. So let's go to Filo del Sol. Now, this is the same scale as the previous images. That's 3 kilometers down there, okay? And so what we have is sort of a true color image from Sentinel-2. So it's a picture from space, and we've draped on top of that, and we can see where there's snow and where there's lighter zones of all hydrothermal alteration, which tends to bleach the rock. And you can see drill roads in here, okay? And then we're seeing the same minerals, the ASTER mineral models that we used in the previous slide for Tambo Sur, muscovite in blue, paraffinite, kaolinite in yellow, and the jarosite in red, and then distal chlorite epidote propolytic. So now let's compare that to the mapped geology. Okay, and this is, you can get this from Filo del Sol's website from their 43101 reports, and I'll summarize this for you. There's basically a zone of silica and quartz alunite alteration in red, and very strong residual quartz in blue, and the mineral resource here, all right? So let's make that a little simpler there. So there is the mineral resource, all right? Extending almost 3 kilometers north-south, open to the south, crossing the Argentine-Chile border here in the black line. We see silica quartz-rich alteration and silica quartz alunite alteration mapped. Now you see that compares very well to the paraffinite and the southern portion of the resource, jarosite, and then it's flanked by the muscovite and further outward halo of propolytic alteration. So we're increasing temperature and increasing the acidity of the hydrothermal fluids going in towards the mineral resource. And again, the scale there is 3 kilometers. Each box here is 3 kilometers. At the same scale, here's the mineral zoning we just showed you from Tambo Sur's 1, 2, and 5. So a similar sort of expression. You know, it's all about having muscovite going into paraffinite with jarosite, All right. And here you would say that perhaps it's so acid that the muscovite is kind of been or is perhaps at depth. This is a very large lithocap. Yes, it is a larger lithocap than the Tambo Sur 1 and 2. However, you look at the size of the resource and you compare it to the size of the alteration inferred from the satellite data for Tambo Sur, you can compare the sizes at the same scale. Now, one thing that I thought was interesting when I first looked at this data, I said, well, geez, there's a lot of silica alteration mapped here, but the ASTER clay minerals didn't show. In other words, it doesn't have the prophyllite is in yellow and the jarosite, the iron oxide's in red, and the muscovite's in blue. But this zone here did not have an ASTER mineral response. So then that's okay, because if we look at the thermal response, which is the silicification or the residual quartz, we see how if you integrate that with the mapped alteration, now we're starting to see a better occurrence. So where it's red, there's more silica. If we go ahead and layer this with the clay minerals, clay mica minerals, and we integrate the thermal or the silica alteration in red with the abundance of micas colored, now we start seeing something that makes a lot of sense. So in other words, we have a characteristic of residual quartz or silicification associated with the prophyllite, flanked by the jarosite and muscovite. And that's the expression of the Filo del Sol system from space, as modeled by Fathom Geophysics and interpreted by myself and Belararox. So we'll go ahead and see again. You see where we don't have a lot of these kaolinite phyllic iron oxides, you get zones that apparently are lacking in an alteration, but we know again, this is a zone of basically just quartz and very rich silica lacking the micas, when the micas are reflected in this particular image. So again, integrating the mapping with the silica alteration inferred from the astrothermal response with the astral mineral models, we have a cohesive picture that makes sense. Look at that major zone of intersection here in the southern portion of the mineral resource. So there's our integrated understanding of Filo del Sol. So I think if we understand the processing of the ASTER data and Sentinel-2 data and integrate it with known mineralization, we come up with basically a pattern that can be applied elsewhere for prospecting in the TMT project area. Veladero also is quite interesting. This is the thermal response, which is consistent with lots of silica or residual quartz at Veladero, but then all the flanking zones of clay and mica, blue muscovite, kaolinite, prophyllite in yellow, jarosite, weathered sulfides in red. So integrating these two models is useful, and we can compare that to mapping as compiled by a PhD thesis in 2012. And you can see in red is the zone of quartz alunite. And the ultimate open pit is going to be about this size. It's similar to that in outline already. Let's summarize that. There you go. So you can see that much of the Veladero was a dome. It was a pre-mining dome with quartz and alunite that did not show well up in the ASTER mineral models and for these micas shown here, or the Sentinel-2 jarosite. But when you integrate it with the thermal response, which is telling us about all the silica, it makes a lot of sense. Look how well the map quartz alunite agrees with the silica alteration inferred from the thermal response and the mineralization. So as one mines downward, you get through the silica cap into underlying clays and muscovite minerals. So I guess we could say is that using Veladero and Filo del Sol as examples, this ASTER and Sentinel-2 stuff works. Okay. So we showed you how it worked at Tambo Sur and the skies there, and it's a nice anomaly, particularly in the south part of Tambo Sur. Now we can go to Malambo, which is kind of in the central to southern portion of the TMT project. And this is, again, the satellite Sentinel-2 true color imagery. You can see snow here. You can see zones of lighter color, which is alteration. And the mineral model is showing us that there's clearly jarosite, prophyllite, and muscovite flanked by chlorite and epidote. All right, so I've simplified that interpretation. So again, this is the same scale as all the other diagrams. So this is a zone of about 2.5 kilometers long, with a lot of acid clays and weathered sulfides, which could be very consistent with a lithocap. In other words, the upper parts of an epithermal system. We can see the main strong north-northwesterly structure and the west-northwesterly and northeasterly cross structures inferred from the iron oxide kaolinite phyllic alteration. I've put in my favorite structures there. I'm showing you the zoning. So again, about a 1.5 kilometer zone of clay alteration consistent with the upper levels of an intrusion-related system. So that's interesting. Toro, going further to the south, has got two very strong targets. A southern target that at surface is muscovite dominant with jarosite, and you'll see that there'll be praphyllite hiding in there. I'll show you that in more detail. And a zone of praphyllite and jarosite to the north. So this is looking like more ordered, higher temperature alterations closer to a heat source to the south and more distal alteration to the north. So I've simplified the interpretation there, showing you the zone of praphyllite, muscovite, and the praphyllite jarosite to the north and jarosite to the south. So again, we can see this on a major northerly trending structural zone at the intersection of west-northwesterly and northeasterly structures. This particular zone of west-northwesterly alteration coincides with a geological belt that goes all the way to the coast in Chile and hosts mineralization, Cretaceous porphyry systems at Cordillera with another group I'm working with, which has got gold, silver, copper, molybdenum, and then through the IOCG belt. So some of these ASTER inferred alteration zones, certainly you can see from space, and they go across the Argentine-Chile border all the way to the coast. And they're hosting mineralization, not just of the last sort of 3 to 10 million years old, but some of these structures have been active all the way back to 100 million years ago, and they just keep getting reopened with time. So again, the inferred structures, throwing on the mineral models there, my interpretation of those mineral models, and showing you that the southern target indeed looks like it's higher temperature. It's more crystalline muscovite, so it's consistent with a heat source and a potential porphyry center at depth. So you can see it's weakly elevated crystallinity, moderately, highly. So there's an increase in temperature vector to the south. Okay, just draping everything together. So lovely structural interpretation and center here of higher temperature alteration, lower temperature alteration here. So if we zoom into that southern zone, which has been drilled, all right, there's a number of drill holes which you can read about on the company website and announcements. We have 2 phases of drilling, the black and the blue holes, and this is draped upon basically the Sentinel-2 true color alteration or image. And you can see again, the lighter colors here are at hydrothermal alteration. This has been confirmed by field work. And you can see the structures that can be pulled out of the iron oxide kaolinite phyllic interpretations. You can see the mineral models here. Now we're zooming in and I'm imaging it a bit better to show you that they're indeed not just muscovite in blue, but praphyllite in yellow and jarosite. So this is getting quite interesting. So this existing drilling has given us epithermal silver, zinc, low gold, very minor copper results in drill hole. In the drill holes, if you kind of look at the reported intervals, there's a ratio of copper over zinc increasing towards the south, and there's better copper in the drill hole results to the south, which is consistent with an increase in temperature. And we've seen this from the minerals that we're seeing in their stabilities, and also from the higher muscovite crystallinity. Okay, so it's all pointing us into this direction of strong alteration, which could be interpreted as a potential lithocap about 500 by 300 meters in size, which could be the top of a porphyry center, which needs to be drilled at greater depths. Many of these holes are less than 200 meters deep. Deepest hole here is about 500 off to the north. And what's very interesting is that to the south and the west, there's been a recently discovered copper-bearing breccia pipe, which has got enargite and chalcopyrite, again consistent with formation in the high sulfidation epithermal system or upper parts of a porphyry, and with some of the trench results in the road are indicating interesting values of copper, 0.3, 0.5% copper. So this is all consistent and basically saying this area needs to be mapped, as do the other target areas, and needs to be sampled systematically with rock sampling, trenching, soil sampling, and then drilled. So we're almost at the home there. Again, just bringing up the drill holes completed to date, and the sort of interpreted lithocap and this hydrothermal breccia pipe. The southern area is over a kilometer east-west, is of high interest. So basically, to summarize, the TMT project's in the right region. We can see that from geology. We can see that from hydrothermal alteration visible from space. We can see that in gravity. These cross-arc structures, these northwesterly things, are very big and long-lived and go all the way to the ocean. The satellite-derived ASTER and Sentinel-2 data, I believe, does a very good job of delineating hydrothermal alteration in known deposits. And we can see that from comparing it to the distribution of known deposits and getting into a very detailed scale at Filo del Sol and Veladero. And then applying what we've learned there to determining targets elsewhere in the TMT project area, some of which are already known, the Tambo Sur 1 and 2, Tambo Sur 5, Malambo, and Toro, but other targets of interest that are not well known that will certainly warrant field investigation. And so again, just comparing the case studies of Filo del Sol to Tambo Sur, Malambo, and Toro at the same scale, and Veladero, we can see that all of these areas are indicated by a high silica thermal response in ASTER, paraphyllite and jarosite, indicating sort of sulfides and acid alteration, which you might find near a porphyry center, with flanking muscovite of high crystallinity, telling us higher temperatures in intersecting linear zones of iron oxide after sulfide weathering, kaolinite, phyllic alteration. We see that Filo del Sol, we see that at Veladero, we see that in the Tambo Sur 1 and 2 target areas, Malambo, Toro. Toro has got two centers. The southern center seems to be of higher temperature, potentially closer to a porphyry center than the northern area, which is not well understood. And historic drilling in the southern portion of Toro is giving us silver, zinc-bearing intermediate sulfidation veins and mineralization, which seem to increase in copper towards the south, where you have this inferred 500 by 300 meter lithocap based upon the abundance of muscovite, paraphyllite, and jarosite. There's also a breccia target coasting copper-bearing copper sulfide minerals in this area, which again is consistent with this sort of proximal to a porphyry high sulfidation epithermal gold, silver, copper system. So that needs to be better understood and geologized by mapping and by geochemical sampling to focus future drilling. So thank you for your patience. And now I'll open this up to questions for Jason or myself. Let me just turn off my screen so we can stop sharing, and then I'll be able to see everyone now, because I was kind of flying blind previously. Great.
Yeah, thanks heaps, Steve. It's certainly really exciting. We can see we've got all the right ingredients there that one needs, so we just got to go and do the work now, which is the mapping and sampling, and we're waiting for our EIAs to be granted. Our environmental permits should be granted soon, and leaving us the beginning of the season in about September to commence field work, to get up there and do all the necessary work. And we'll certainly be inviting Steve up for a field visit as well. So we'll open it up for questions.